Hey guys, this is JSer. How's everything going? In this video, I'm going to take a look at 14771, the kth strongest values in array. Actually, I did just just today in a live contest, but I didn't make it. Actually, I did solve this problem, but I made a TLE problem. I didn't know what happened at that time, and after the contest, I did dig a little, and I found that I made a small mistake of writing the conditions of the priority queue. Oh no, of the quick select. Okay, I'm going to review this problem once more. I hope it helps. Okay, let's begin. We're given an array of integers and k, and a value is said to be stronger than j if the difference between the median are larger. If they have the same difference, then the larger one will be stronger, okay? And we're going to return a list of the strongest k values. Return an answer in any arbitrary order is okay. So the median is the middle value of the ordered integer list, okay? And the input might have duplicates. Okay, so yeah, let's try to do it. The first step we need to do is get the median, right? Get the median, and then we get the top, right? Get the top k. Well, we can do it naively, and we'll just sort the array first and get the median. Okay, so we first sort it. Sort. So the median would be ARR, the index would be math floor. It says, yeah, this. So ARR.length -1, right? And yeah, this should be divided by 2. Okay, so this is the median. Now we get the top k. Well, the naive solution is that we sort it again. Const difference. Diff A equals math floor. Oh no, math ABS A minus median. Const diff B equals math ABS B median. If diff A is smaller than diff B, then we return 1, right? We need the maximum, so else if diff A is bigger than diff B, return -1. Or if they are the same, we return A minus B, right? If A is bigger than it, then it must be closer. It'd be, yeah, this is right. So, and then we could just return the ARR slice 0 k minus 1 plus 1. This is it. This is a naive solution. Oh, actually we made a mistake. Top k 0 k plus 1. God. Made small mistakes. Yeah, let's submit. What? We made a mistake? Huh? Wait a minute. If A is bigger than B, then it should be, I'm sorry, should be. This is descending order. Wow, I always make these mistakes. So we are accepted, and let's try to analyze, but this is actually not the best solution, I think. Let's first analyze the time complexity. Time for n, this sort, right, is so n log n plus this is n log n, and slice k, so actually it's n log n. Actually it's this plus k n log n, right? Space, nothing, so constant. This is not the original solution I did in my contest, but this is a brute force. I think this will be triggering the TLE, but actually it did not. I tried to solve it with a more clever way. Let's try to do that. The idea is to get the median to get the median, we actually don't need to sort all of them, right? We don't need to do. We might actually sort a little bit, half of the node, and it's called quick select. Let's try to do that. Oh, okay. It's get strongest. The idea is get median through quick select. And so we could improve that, improve the sort method. Let's do it. Let's start with 0. Let n equals ARR net. So let median index equals math floor start and okay, let median. While start is smaller or equal to n, what we do? We will choose a pivot, do the quick sort, and if the new index for the pivot is right, the target we want, we just return it. So we could just probably terminate the while loop in the middle of the loop. So we can save a lot more time. Okay, we choose a pivot. We just put it as start and let the index to swap equal start plus 1. For let I equals start plus 1 as smaller than n to n. If ARRI is smaller or equal to, this is the solution I did in the contest. So if it is, we need to choose, if it is smaller, we will put it into the index to swap, right? So if puts the smaller one to the left, put the bigger one to the right. If it is smaller, to pivot. Oh, I made a mistake here. Ooh, I'll swap it. So do the swap, which is ARR index to swap. ARR I equal to ARR I ARR index to swap. We swap it. After we swap it, we need to index to swap, move to the next one. If it is bigger, we do nothing because we only because the bigger ones will after the index to swap. So yeah, it's cool. So when this all ends, we swap, right? We swap the pivot to the index to swap the previous one. Okay, so ARR index to swap minus 1 ARR pivot. Oh no, the start equals to ARR start ARR index to swap minus 1. Cool. So now we have to do one round of the partitioning, and if so the pivot actually will be moved to index to swap minus 1 if that's the median index, we can return right away, right? Index to swap minus 1. If it is equal to median index, we will break, right? We just say median equals to ARR median index. Cool. Or if index to swap minus 1 is smaller than median index, it means the median is to the right part. So we move start equals to index to swap, right? Minus 1 plus 1. Okay, for the other cases, the median will fall on the left part. So equals to index to swap minus 2, minus 1, minus 1. Yeah, while this all ends, we find the median. Cool, so this is better than the sort, I think. Well, I'll try later to see what happened. First, this is quick select. And then we need to get the top k, right? Top k elements. So this is top K problem. As we said before, there are a few videos on my channel about priority queue. We just use a priority queue. Okay, I'll copy paste the priority queue. There's another video introducing how to implement the priority queue in JavaScript. I'll skip it here. Just tell the interviewer that we can suppose we have priority queue. Okay, and now I'll just create PQ priority queue. So the order is it depending on the relationship about the definition of stronger. So the stronger values will be farther from the root because the root will be deleted. So we actually will do the same here. We copy the code here. The div A is the median. Okay, the div B. If div A is smaller than B, then return -1, right? It will be closer to the root to be removed. If bigger, okay. And then if it is smaller, then it should be removed. It should be closer to the root, so A minus B. So this is our priority queue. So now we will loop through the array for let num of array pq at num. If pq size is bigger than target, right? It says, what is target? Okay, there's not target, it's k. We poll, right? So this pq priority queue will be always the length of k, and at last we get the result. While pq size is bigger than 0, result push pq pq poll. Cool. And then finally we return the result. The arbitrary order is okay. Let's try running code. Cool. I think we're okay. So it's wrong. So this actually is what I did in a live contest, but I met a TLE. Yeah, TLE. You see, the input is like this. Wow, these are all 2s, and but generally they first analyze the time complexity here. For the quick select, I think for worst case, averagely will be better than O n log n, right? But for the worst case, averagely, I think it should be like n log n averagely. But for worst case, of course, for worst case, it's O square, but it's generally the same for the sort. So it doesn't change time complexity. For PQ here, for every number, and it will be used to be add and poll. So yeah, log k, right? It's better. Okay, so that's all the result. That's all the time complexity. I think it should be improved, but actually it didn't. And I didn't know why. I realized that when all the elements are 2, what will happen? Let's see. Suppose all are 2. We first choose a pivot, and then this is smaller, so we swap it, right? Swap this 2 to 2, 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 and then we swap the 2 to this 2, right? And then we start it again. Like and check this too. So this actually is meaningless. We'd better keep it simple, and if we remove this equal case here, we won't do that. So you see, pivot here, we do nothing, do nothing, do nothing, do nothing, and actually we will go to this 2. The count of the check doesn't change, but we don't do the swap, unnecessary swap. You see, we didn't swap it, so yeah, it's actually slightly better. That's what the problem happens. Let's submit. Cool. We actually accepted, but You see, for previously we used 300 millisecond, and now we have like 4 seconds. Well, it's much slower actually. It's I don't know why slower with the priority queue. But personally, I think this is better. For the extreme cases, yeah, for averagely, I think this will be better. For extreme cases, I think averagely this is better, but with complexity unchanged. Well, I think for interview, I think we should solve the solution like this and try to improve it little by little. Forget the median, we use the quick select, and for the top K, we use priority queue. Yeah, something like this. Well, there are 2 solutions to this problem. Hope it helps. See you next time. Bye bye.